Okay, this video is on getting to know the radian measure angles a little bit better. I wanted to kind of zero down what you need to know. Really, you need to know really well the multiples of pi over 4 and the multiples of pi over 6. So I'm going to draw two circles to represent that. You know that pi over 4, well, hopefully at this point you know that pi over 4 is the same thing as 45 degrees, and we can discover that by taking a complete trip around the circle, 2 pi, and dividing it by 8, because as we know, 360 divided by 8 is 45, right? So if I take 2 pi divided by 8, I get pi over 4, okay? So that means if I put a little line halfway between each of my axes, that represents the pi over 4 increments. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, etc. on around, okay? So that's really helpful if you think about it that way, that if I say, for example, give you the angle 5 pi over 4, really all you have to do is count pi over 4. So that would be 1, 2, 3, 4, 5, and that tells you that 5 pi over 4 is exactly between the negative x-axis and the negative y-axis, which puts me in the smack dab middle of the third quadrant, okay? Oh, and just a quick reminder that it goes first, second, third, and fourth quadrants. That's the way the quadrants are numbered, okay? Likewise, if I was to say, where's negative 3 pi over 4? Negative means I go in a clockwise direction. So that would be 1 pi over 4, 2 pi over 4, and 3 pi over 4. Oh, it's the same place. Look at that. Negative 3 pi over 4 and 5 pi over 4 are, what do we call those things? That's right, coterminal angles, because their terminal side is in the same location. So any pi over 4 multiple will be somewhere on this circle. So one of the lines will end up on one of the lines. Notice that if I go pi over 2, we already know that's here. Hopefully you've established that, but notice that pi over 2 is the same thing as, whoops, not that. It's the same thing as 2 pi over 4, isn't it? So notice you go 1, 2. That's the same thing as 2 pi over 4. So you can find your way around the circle with multiples of pi over 4. Also, pi over 6, which happens to be the same thing as 30 degrees, and again, that's something you hopefully figured out at this point. So that's really taking the 2 pi and dividing by 12, because there's 12 30-degree angles to add up to 360, right? So that means I'm going to have 1 there, and 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 1 there. So these are 12 evenly spaced or same size sectors, if you will. And each one of these angle rotations, whoops, excuse me, each one of these angle rotations is pi over 6 or 30 degrees. So once again, if I'm looking for something like 7 pi over 6, all I have to do is count. 1, 2, 3, 4, 5, 6, 7. So that'd be right here. Notice this is the x-axis and that's the y-axis, right? So, or another way to think of this is even 6 pi over 6 takes me right here, right? 7 pi over 6 would just be 1 pi over 6 further. So one thing that you need to do as a student is to get very good at finding your way around the circle when I give you some multiple pi over 6 or some multiple pi over 4. Notice like we did over here also, if I have 5 pi over 3, even though that's not a pi over 6, we know there's equivalent fraction that would be 10 pi over 6. Yeah? We all know that? Because I multiply top by 2. So I can find 5 pi over 3 by just counting again. So now 10 pi over 6, I could count around like this until I hit 10 pi over 6. But I also realized that 12 pi over 6 is the same thing as 2 pi, which would take me all the way around. So this would just be 2 back from that. So 10 pi over 6 would be sitting right here. Okay? Or if we did, say, I'll change color and say, what if we did 5 pi over 6. Well, that means I would just go 1, 2, 3, 4, 5. That would be right there. Or I could think 6 pi over 6 is right here, so I go back pi over 6. That would also put me right there. Okay, so that's finding your way around the circle in radians. Hopefully this little lesson helped you get better at that, because you can, this is something you need to really need to be good at. So practice that. One thing to point out is when I'm dealing with pi over 6s, notice there's 2 different angles that are involved in the pi over 6 in each quadrant. So really, it's really important to be able to distinguish between which one is closer to the x-axis and which one's closer to the y-axis. That's really, and you'll notice that these are all pi over 3s, aren't they? Because that would be 1 pi over 6, 2 pi over 6, which is the same thing as pi over 3. Oops. That'd be 3 pi over 6, 4 pi over 6, which is the same thing as 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is the same thing as 4 pi over 3, 9 pi over 6, 10 pi over 6, which is the same thing as 5 pi over 3. So all these ones that are close to the y-axis are going to be pi over 3s, and all the ones that are close to the x-axis will be pi over 6s. All right, so there you go.